Welcome back. This is Mr. Wakefield, continuing on with Chapter 7, continuing on with talking about sequences. And we have a special kind of sequence here in this section, and then we'll have another special kind in the next section, 7.3 as well. In this section, we're going to be looking at arithmetic sequences. Arithmetic sequences, let's read the definition here. It's a sequence that starts with any number. It could be any number at all. But then after that, from the first term to the second one, and then the second to the third, and so on, it will always change by the same amount, called the common difference, and we call that D for short. Okay, we'll use the letter D for that. But what do we mean when we say it changes by the same amount? In particular, it means that we add the same amount to each previous term in order to get to the next term. You can see that that's what happens here. 5 plus 3 is 8. 8 plus 3 is 11. 11 plus 3 is 14, and it just goes on like that forever and ever and ever. That's why we have the dot, dot, dot. It means it just keeps on going forever. So the next term after 17 would be 20, and then after that 23, and then 26, and so on, so on, so on. Okay, and so the common difference in that case would be 3. And what if we had something like this? So let me just give you another example here. 5, 3, 1, -1, and so on. Okay, this also qualifies because even though the numbers are getting smaller, all right, you're adding -2. All right, same thing as subtracting 2. Remember, when you subtract a positive number, like subtracting 2 right here, it's the same thing as adding -2. All right, so isn't it true that we're subtracting 2 to get from one term to the next here? Okay, 5 minus 2 is 3, 3 minus 2 is 1, and then so on. So when that happens, when you subtract a positive number and it's the same number, same positive number you're subtracting for every single situation here from one term to the next, okay, then that means that D is negative. Because again, when you subtract a positive number, in this case subtracting 2, that's the same thing as adding negative. And the D is whatever common number that you're adding officially. And so that's why the D has to be negative when you're subtracting 2 from one term to the next to every single term there. Okay, so we have these formulas here. I'll get to these in a minute, okay, but I want to talk about, first of all, before I get into these, and you can see they look so similar to each other. The only difference is that the K here is when you have a constant number that you're using, and whereas here, this is a variable N. All right, well, again, we'll get into that here as we go along. But before I come back to these formulas, let's flip the worksheet over. I want to tell you the approach that we're going to take on these problems. It says arithmetic sequence strategies. And I want to make this really clear, you guys. We're just talking about arithmetic sequences. They're not other sequences. When you have arithmetic sequences, I'm going to look at the strategy letter B first, all right, because A is going to tie into that actually. So strategy letter B here, it says, if you know what D is, along with one term in the arithmetic sequence, if you just know those two things, if you know what the common difference is, all right, and you know just one term in the sequence, it could be just one, all right? You might know more than one, but even if you just know one, then that's enough to figure out anything else in the sequence. You can use these two things, the D and the one term, to find any other term in the sequence, and you can also find the AN formula. What's the AN formula again? Remember AN, you guys, just a reminder from last time in 7.1, we talked about how AN is similar to f of x, where it is the actual formula with the variable in it. Whereas if you've got like A1 or A2 or A3, that's the same thing as plugging in 1, 2, or 3 into a function, all right? Where there's no variable anymore after you plug it in. So like if you've got A sub 1 or A sub 2 or A sub 3, in this case A sub 1, all right, you're actually going to get an answer with no variable in it. But for A sub n, that's the actual formula itself that has the variable in it, just like f of x has the variable x in it, all right? So it's saying here that you could figure out, if you know these two things right here, D and one other term in the sequence, all right, then you can use those two things to find any other term in the sequence. In other words, you can figure out A sub 1, A sub 2, A sub 3, A sub 86 if you wanted to. You can figure out the 86th term in the sequence if you wanted to. You can figure out any term at all, okay, and also you could figure out the sequence formula A sub n. And we're going to be doing stuff like that here as we go along. Now, speaking of that, I'm going to flip over back to the front side of the worksheet. These two formulas right here, this is just what we were just looking at. Again, this is what you would use if you're just trying to find another term in the sequence. Okay, so the k is meant to be a constant number, like for example, a sub 8 or a sub 10 would go here. And then you could use this formula to figure it out. Whereas if you wanted to know just the general formula, then you would use this one, and then the n would be a variable instead of a constant number. Okay, I know these things look kind of complicated right now. I'm kind of getting all theoretical on you. I apologize for that. But don't worry, as we use these things as we go along, all right, it'll start to make more sense to you, okay? But see that these two formulas are basically the same thing. The only difference is that instead of an n down here, you have a k up here, all right? The rest of the formula is completely identical, all right? But I just wrote it this way to indicate that sometimes you got a variable n, and then sometimes you got a constant number that's in the place of k here. That's really the only difference. But let's learn about how to use those two formulas here as we jump into the first problem. Notice in the first problem it has a term in the sequence, and it also has D. And we know that it's an arithmetic sequence not only because it says that it is, but you can kind of tell when they say D, all right? We usually don't use D for other sequences besides arithmetic. So we know it's arithmetic. Because we know it's arithmetic, then it tells us up here at the top that if you know D in one other term in the sequence, you can figure out anything else that they ask for. All right? What does it ask for here? It asks us for the first 5 terms of the sequence. All right? And so how do we figure out the first 5 terms? All right, well, if this is the first term, let's write down, just like we did the other day in 7.1 when we figured out the first 5 terms. All right, let's just list it out here. Because the D is -2, you guys, all you got to do is just add -2 to the previous term to get to the next term. That's all you got to do, okay? And remember, when you add negative, that's the same thing as subtracting +2, isn't it? So 5 minus 2 would be the next term. The next term would be 3 minus 2. Okay, you just got to take, again, the previous term to get to the next term. That's how it works with D. Okay, so 1 plus -2, same thing as 1 minus 2. And then finally, -1 plus -2, same thing as -1 minus 2. And there is your 5 terms right there. Okay, we did it. Let's do that same thing again over here in problem number 2. All right. So we got what here? We got we already got A1. So you just have to add the same amount to each previous term to get to the next term. The D this time is 3. And so we just say what? We just say 4 plus 3 is 7. 7 plus 3 is 10. 10 plus 3 is 13. And 13 plus 3 is 16. That's how arithmetic sequences work. You add the same amount to each previous term to get to the next term. And if that same amount is negative, you could also subtract the positive equivalent. Subtracting 2, same thing as adding -2. So that's how you'd figure out the first 5 terms. However, suppose they just say, as we move on to the next problem, suppose they just say, hey, we need you to find a random term, like out of nowhere, like for example, a sub 8. Could you figure that out without having to figure out a sub 2, a sub 3, a sub 4, a sub 5? Could you jump straight to a sub 8 and figure that out without having to actually do all of the terms that are before that? You actually can, okay? And I'm going to show you how to do that, all right? But notice here, you guys, and this is the key thing. Notice that we have actually 3 terms. We only need 1, but we actually have 3 terms here of the sequence already. But we also know what D is just by looking at this. Can you see what D is just by looking at this? And we know that there's a D because it does say it's arithmetic. All right, there's no mystery here. There's going to be a common difference. All right, we call that the letter D. Okay, what is that common thing that gets added to get from one term to the next here? Okay, well, we can see that -3 minus 4 is -7. And we can see that -7 minus 4 is -11. And when you subtract a positive number for each situation to get from one term to the next, that means that D is not 4, but it is negative 4. Okay, when you're subtracting 4, that's the same thing as D being negative 4. Okay, so what we have now is we have actually 3 terms here that we know, but we only need 1 along with the D, as it tells us up here. If you know D and at least one other term in the sequence, you can then figure out any other term, and that includes a sub 8. You can figure out a sub 8, you can figure out a sub 10, you can figure out a sub 23 if you wanted to, anything you want. How do you do that? Okay, well, that's where we go back to those formulas on the front. It says here, and let's follow it along here. Remember I said that you use this one right here when you're actually trying to figure out a specific term as opposed to the formula a sub n. So like, for example, if you wanted to figure out a sub 8, let's write this in here. A sub 8 right underneath it here so you can see. You could pick any term, any other term in the sequence that you know. Okay, I know, and we're going to put it there, but you could pick the first one, the second one, or the third one. As long as you put any other term in the sequence here, that's fine. It could be any of them as long as you know it, because you got to put something here. Okay, so I'll go ahead and use negative 3. Since negative 3, and let me just write down a sub 1 right here. I'll put the negative 3 in there in just a moment, okay? But I want to show you something here, so that's why I wrote a sub 1, okay? So this is the 8th term that we're trying to figure out. We're going to use the first term because, again, we need to know one other term in the sequence so we can use it. We're going to make a sub 1, the first term, to be that one other term. And then we also need to know what D is. D is what again in this problem? It is negative 4, isn't it? So I'm going to put that over here. Put that in parentheses because otherwise it's going to look like you're subtracting here. And then what goes inside this bracket right here? Okay. Check this out here. See how this is K and I right here? AK and AI, and then this says K minus I. So that means that the bracket just means that you have to take these two little numbers that are underneath the A and subtract them. Like that. Okay, bring down the plus there also. Okay, so what does that mean? That means that a sub 8 is equal to a sub 1 plus 8 minus 1 times negative 4. So all you got to do is you pick a term that you want to use right here. You put the term you're trying to figure out right here. Okay, and since we haven't figured it out yet, I'll just put a sub 8 right there. But I'm going to use a sub 1. Okay, and then you just take those two little numbers and put them in here and subtract them. It's got to be in that order, though. You can't say 1 minus 8. It's got to be 8 minus 1. Okay, so what do we get here? We get a sub 8 is equal to, and what is a sub 1, you guys? It is negative 3. Okay, plus what? 7 times negative 4, right? 7 times negative 4. All right, so plug in the term there that's right after the equal sign that you're going to use, and then at that point you just have to do order of operations right here. That's all you got to do. So let me go ahead and transfer that particular set of steps there back over to the problem. I got a sub 8 is equal to negative 3 plus negative 7 times, I'm sorry, positive 7 minus negative 4, or pardon me, times negative 4, excuse me. And so I just transferred that over here. Let's go ahead and figure it out now. There's no variables here, all right, so I just need to do order of operations to figure out what this is equal to, and then it'll tell me what A8 is. So that is what? That is negative 3 plus negative 28, and that is going to be negative 31. So that means that the 8th term in this sequence, you guys, is negative 31, and you didn't even need to figure out what the 4th term, the 5th term, the 6th term, the 7th term. You didn't have to figure out all the terms before it like we had to in the previous problems here. Okay, not that you had to in these problems. It was just it wasn't that hard, so I went ahead and did it. But the point is that you don't have to figure out A3, A4, A5 in order to figure out A6 or A8 or A11. the 11th term, whatever it may be, you can jump straight to it with that formula that we just used. Okay. Speaking of that formula, remember I said that the formula for AN is practically identical. Okay, let's write it down side by side here, in fact, so you can see that once again. A sub n, once again, you guys, you use the same stuff, all right? It's just that instead of putting the 8 in there, because the 8 is the constant number here, we're now going to have the n in there. The variable is going to go there instead of the 8. So since this is a sub 8, you're going to put the 8 there. If it's a sub n, then you're going to put the n there. So whatever this little sub number is underneath the a, that's what goes, that's the first thing that goes inside the bracket. Otherwise, you do exactly the same thing on the, whether you're doing a sub 8 or a sub n. Okay, so let's do that same thing again. So we're going to do a sub 1. Not that you got to do a sub 1. You could do a sub 2, a sub 3 right here. You could do any of those. Just know that if you do a sub 2 right here, then you got to do n minus 2. If you put a sub 3 right here, you'd have to do n minus 3. Remember, the bracket, the bigger bracket here, is equal to these two numbers being subtracted. Okay, so that's why if this was a sub 3, this would have to be n minus 3. Okay, what is a sub 1 again? Go ahead and plug that in. You could have plugged it in right away there. I know I could have done that. It's just that I wanted to really emphasize how similar these two formulas are by putting the a sub 1 in there like we originally did in the last part here with the a8. Okay, but you could have put the negative 3 in there right away. So we got this right here, but it's got a variable this time. When you use this formula right here, you guys, yes, this is a sub n, okay, that's what they asked for, but they want you to simplify this. And the way to simplify this, kind of like when we do linear equations, if you've got a term, I know it's normally in front of the bracket, but if you've got a term, just a single term, being multiplied by a bracket with two terms in it, you distribute that, okay, like that right there. And then because there's a plus in front, you don't need to do any sign changing. You just do the same signs. But remember, it's got to have a plus or minus in front of each one of these two answers. Okay, so when I distribute, since negative 4 times n, and just bring down the negative 3 for the moment, but negative 4 times n is negative 4n, so make sure to say minus 4n. But negative 4 times negative 1 is 1. And like I said, like we normally do when we distribute, you got to have a plus or minus in front of each. Sorry, that I meant to say 4 there, not 1. But make sure that you have either a plus or minus in front of each term that you get when you distribute there. And so that's why I put the plus right there instead of just saying 4. Then after you distribute out that parenthesis, again, similar to when you solve linear equations, you then combine like terms, and then we'll be done. If I do that, I get negative 4n plus 1, don't I, if I combine like terms right there. And that, you guys, is what you get for a sub n. Now, what if I had done a sub 2 right here instead of a sub 1? The problem would have looked different at first. At first it would have looked different. But if you then do the thing where you distribute and combine like terms here, I promise you the answer will be the same in the end, no matter what term you put here. Whether it's a sub 1, a sub 2, a sub 3. It'll look different at first if you use a different term right there, but it will come out the same in the end. And so then when you compare your answers to the back of the textbook, for example, it'll still look the same in the end. Don't worry about it, okay? And so you'll be fine. And so that is how to find a sub 8 and a sub n. You'll see in this next problem, though, this is a little bit different. They don't tell us what d is this time, but they do give us a couple of terms in the sequence. And this is good because as it mentions up here, it says here, if you know, and this is the other strategy that we need to be aware of. Actually, let me give you a more clean look at it there. There we go. If you know two different terms of an arithmetic sequence, which we do in problem number 4, you can use those to find d. Remember, you guys, you need to know what d is, and you need to know at least one other term in the sequence. In this problem, they don't tell us what d is, but we can figure it out. Okay, if they give you, if they don't give you what D is, but they give you two different terms in the sequence, you can use those two different terms to figure out what D is. All right, let me show you how to do that. What you use, in this case, you really, there's a shortcut to this actually, since these two terms are right next to each other. There's a shortcut to this. I'm not going to lie to you here. I'm going to do it just for practice though, because we need to know the long way as well for the next problem. I'm going to do it both the short way and the long way. I'm going to do it the long way first, okay? Again, just for practice. The way you normally would do it, if you wanted to figure out what D was by using two terms in the sequence, is you would take your formulas, okay, and since we're not doing a sub n right now, we're just doing two terms in the sequence. What you do is you put those two terms right here. Okay, so what I'm going to do is I'm going to erase this old problem here, so I'll have room. That problem that I just did. So if you know two terms in the sequence and you want to know what D is, you can also use this formula here. Here's what you do. Okay, what does it say here in this current problem? It says that we know the 15th term and the 16th term, right? So here's how you do it. You can, and it doesn't matter what order you put this in as long as it's consistent with the order over here. I'll get into that again here in a minute. So if I put A15 right here, and I put A16 right here, okay, so I've got A15 first and A16 second. Again, it does not matter which order is which. Let me zoom in so you can see that better. So you've got A15 and A16. All right. Because it's in that order right there, remember I said that the bracket is equal to these two numbers subtracted, but it's got to be in that order. So since I've got A15 and then A16, I've got to say 15 minus 16. If I had put the 16 over here and the 15 over here on the right, then it would be the other way around. It'd be 16 minus 15. So it does not matter what order you put these two in as long as this order is the same. That's the most important thing. Okay. All right. Then you put the D here, and now we can solve for D. Okay, let me show you how to do that. Now notice that 15 minus 16 is negative 1, right? You don't have to keep on writing the bracket there if these are just two constant numbers. If there's no if the n is not in here, like it is when you do the a sub n formula in the last problem, if it's just two constant numbers, you can take a little bit of a shortcut here and realize that this is plus negative 1d. Okay, isn't that the same thing? And let me write this down. Isn't that the same thing as just saying minus 1d, which is the same thing as just saying minus d? All right, so when you subtract these two numbers here, okay, if it's negative, then you're just going to say minus, okay, and then the number, in this case minus 1, and then the d. If this had been a positive number in here, okay, then you'd say plus. And you'll see an example of that here coming up, don't worry. So you don't have to keep on writing that bracket there unless the n is in there. If the n is in there, then you got to write it, because then you'll have two terms in there that aren't like terms. So you got to keep them bracketed. All right. As you guys know, when you have two terms that can't be combined and they're being multiplied by something like d, for example, you got to keep it bracketed. Okay. So now what I do after I just set that up is I plug these two numbers in. The 8 goes here because that's the 15th term. The 5 goes here, and then you'd just have to solve for d. That's all you got to do. Okay? But that's the formula you use. All right? We'll see a similar example in the next problem here if you're still trying to get used to that. No problem. Okay? We'll see more. What do we get for d? If I move over the 5, I get negative d equal to 3. And then if I divide out, I get d is equal to negative 3, right? Okay, so now I know what d is. Okay, as you guys now know, if you know what d is and you know at least one term in the sequence, and we actually know two of them, we know the 15th term and the 16th term, but if you just know one term in the sequence and you know what d is, negative 3, then you can figure out any other term in the sequence, including a sub 8, like the directions ask for here, okay? And also you could figure out the a sub n formula. Now that I know what the d is, I can just do the same exact thing I did in the last problem. Okay, what did we do for a sub 8? So when we're figuring out a sub 8, just like right here, since I put the first term here, and I have the 8th term right here, then this is 8 minus 1, which is equal to 7. You don't even need the bracket right there. You do need this bracket because you're multiplying by negative, so you got to put a bracket around the negative. But you could just say plus 7 and then times negative 4 there. You could keep the bracket if you want. That's why I have it there. But you could do the same thing I talked about here, where if it's negative, you just say minus. If it's plus, you just say positive without the bracket. So you could have said, like, for example, this right here. And it's going to give you the same answer. Okay, just letting you know. But the bracket's okay. So anyway, if I want to know what a sub 8 is, again, you could pick either one of these two to do here. Let's say that I did the 15th term. I'll plug it in on the next step here. I just want, since we're just getting used to this for the first time right now, I want to make sure we're doing this right. Now, since this is a sub 8 and a sub 15, okay, going back to this formula right here. Okay, and again, let me get rid of what I just wrote down here so we don't miss it, so we don't get thrown off by that. If you put a sub 8 right here, you guys, before the equal sign, and then a sub 15 right here, then that means that this has to be 8 minus 15, doesn't it? A sub 8, a sub 15, let me say that again because I stumbled over my words there, sorry about that. A sub 8, a sub 15, 8 minus 15. Okay, if I had used the 16th term instead, then I would go a sub 8, a sub 16, 8 minus 16. It just depends on what these two little numbers are. All right, so since it's 8 and 15, I'm going to say minus 7d, aren't I? Okay, because 8 minus 15 is negative 7. Again, if this had been positive 7, then you'd say plus 7d. It just depends on if it's positive or negative. So now, in order to figure out a sub 8, I then plug in what I know here. I know that the 15th term is 8, and I know that the d is negative 3. I figured that out on the last step there, and then you just do order of operations. Order of operations says here, since this is just a normal polynomial here, okay, when you got 8, when you got a term minus 7d, that's just a normal polynomial, and as we've talked about before, when you have a term minus another term here, remember that when you do the multiplication here, you do negative 7 times negative 3, because this officially, you guys, is plus negative 7d. Officially, it's plus negative 7d. So what you do is you multiply the negative 7, not 7, but negative 7 times the d, and then you add it because it's plus negative 7d. All right, so you got to add it because of the plus. It's invisible, but the plus is there. Okay, so we got 8 plus negative 7 times negative 3. That would be 8 plus 21, wouldn't it? Okay, and that would be what here? That would be 29. And then to figure out a sub n, again, it's the same exact formula. Same exact formula here. Except for instead of putting the 8 there, you put the n right there, which means that you're going to have n here. Okay, and so we're going to have to keep the bracket there when we use the n, because you're going to have the two terms that can't combine. And so let's use that same formula, but with the n this time. All right, make sure I've got enough room here. A sub n, using that same formula. Make it easier to see here. There we go. So we got a sub n, and then again, you could put any term you want right here. Okay, so you could do any term that you can even use the 8th term if you wanted to. Any term that you know, I could put the 29 right there. Okay, any term that you know, but I'll go ahead and yeah, I'll get, you know what? Why not? I'll go ahead and put the 8th term right there. I'll plug it in on the next step here. You can plug it in now if you want, as long as you know that it's the 8th term, though. Because on this next part here, since these two little numbers underneath the a are equal to n and 8 in that order, then that means that this is n minus 8. Again, it's got to go in that order. So don't say 8 minus n minus 8. Okay, and then the d is negative 3, like that. Okay, and then you do the same thing that we did after I plug in the a8, which is what? That's 29, right? Yeah, definitely plug in. Always plug in the that term that's after the equal sign there. Okay, that's supposed to be part of the answer there. But I just put the a sub 8 there so you could once again get used to this pattern here. N8, N8, same order. But now I do the same thing I did in the last problem with the AN, which is to distribute, and then combine like terms after that. If I distribute here, I get what? I get -3. Bring down the 29 first, though. But we get -3n, so I'm going to say minus 3n. And then I get positive 24. And like I said, when you're distributing here, you want to put either a minus or plus in front of each answer from the two multiplications that you do here when you distribute. And so since this was negative, I got a minus. And since this is positive, I put a plus. After you distribute, you combine like terms. So the final answer is going to be -3n plus 53. 29 plus 24 is equal to 53. And there you go. And you will get this answer right here at the bottom. You will get this answer no matter what term you plug in here. If you plug in the 15th term, you will get this same answer, -3n plus 53, I promise you. Okay, because if you plug in the 15th term right here, yes, that number will be different, but then this will then become n minus 15. And so after you do all the distributing and combining like term stuff, I promise you it'll all come together to be the same answer at the end. It may not seem like it, but it will. Okay, try it. Anyway, going on to the next problem here. Again, it gives me two terms, and then this time they just want me to figure out the first term of the sequence. You don't need to do AN this time. And they don't ask for A8 either. They just ask for the first term. That's fine. Okay, we could do that. Because as you guys know, if you know a term in the sequence, and we actually know a couple of them here as they tell us, if you know a term in the sequence and you know what D is also, you can then figure out any other term in the sequence, including the first one, which is what they're asking for. But what did we say about when they don't give you what D is equal to? But instead they give you two terms in the sequence. You can then use those two terms, okay, to figure out the D. Okay. By the way, I forgot to mention in the last problem, I know I promised you the shortcut. This time, in this problem, you won't be able to do the shortcut, okay? At least not very easily. But here, the reason why I mentioned the shortcut earlier to figure out D is because these two terms are right next to each other, aren't they, in the sequence? 15th and 16th. So 15th and 16th terms are going to be right next to each other. And so you can see, because they're right next to each other, that D must be equal to -3 because to go from one term to the next term, if you have to add -3 or subtract 3, same thing, okay, then that must mean that the D is -3. Okay, because we know it's an arithmetic sequence, so it doesn't matter what two terms you're looking at. As long as they're right next to each other, you'll then be able to look at those two numbers, and you just have to ask yourself, what do I add to the previous term to get to the next term? Well, that would be -3. Just by looking at it, you can tell that. And so that would be the shortcut, is just by looking at it, you'd be able to tell that the D was -3. But I wanted to do it the long way because when you get into a problem like this now, where the two terms are not right next to each other, one of them is the 12th term and one of them is the 20th term, then you can't really see very easily what the D is equal to. You got to actually use the formula. So let's use the formula. In other words, we'll do the same thing we did the long way here in this problem to figure out what D is. But you got to figure out D in order to be able to figure out any other term in the sequence here. Okay. Just like we've been talking about, you need to know D and you need to know at least one term in the sequence. Well, we got the one term in the sequence covered. We could use either one of these two to be our one term that we're going to use. Again, to figure out D, you could use this formula as well. And what you do is you could put the A12 here and the A20 here. It does not matter what order, as long as the bracket here is done in the same order as well. So since I did 12 first and 20 second, then the bracket is going to be equal to -8. And again, you don't need to make the bracket here when there's no variable in there, all right? Since it's 12 minus 20, I can just say minus 8d. Bring down the d behind the minus 8. Okay, so 12, 20, 12 minus 20. That's how it works, right? It goes in that same order. 12, 20, 12 minus 20 gives you the negative 8 right here. Okay, so let's do that again here. You know what, though? Since I keep on getting these minuses every time, which is not always going to happen every time, just to show you that it's going to be okay no matter which way you do it, if you, for example, decided to put the 20 first and the 12 second, that's okay, all right? It's going to look a little bit different, but it'll still give you the same correct answer, all right? But if you've got 20 first and 12 second, then this would then be 20 minus 12. 20, 12, 20 minus 12 is what, you guys? It is 8d. But if it is positive, then you've got to put the plus there. You've got to have either a plus or a minus, okay, in front of whatever this thing is right here when you just subtract the two numbers. I'm not talking about when you got the n. When you got the n, you're always going to have a plus there, and then the n minus whatever goes after that. Okay, as we saw in the previous two problems. But when you have just the two constant numbers that you're subtracting, if the answer is positive, don't forget to put that plus there. Okay, you can't just say 8d. It's got to be plus 8d. Okay, so you could use either one of these two things to figure out what d is. I promise you, again, it'll come out the same. All right, so I'll go ahead and use this one though. Okay, so we'll bring that down. But again, doesn't matter which one you use. So I'm just transferring my work down here. Now go ahead and plug the numbers in. So the 12th term goes there. The 20th term goes here. And then you solve for d. This is just a normal linear equation that we've done so many times this semester because it's d to the first power. Okay, it's a polynomial on both sides. So we move the 60 and the 84 to the same side by subtracting the 84 over to the left. That's why I got negative 24. 60 minus 84 is equal to that right there. And then we divide out the negative 8, and d is equal to what, you guys? D is equal to, isn't it going to be equal to 3? Okay. So there you go right there. And so now that I know what d is equal to, I now can figure out a sub 1 using that same formula right here that I've been using all along here. Gosh, we've used this formula a lot already. All right, I keep on erasing stuff so I can go to the next problem like I'm doing right now. So what do we do once we figure out what d is again? We use what? First of all, what do we want to know? If I want to know what a sub 1 is, it's just like when I was doing a sub 8. Sorry, that fell off the screen there. Sorry about that. Let me start over again here. So we always use this formula when we want to know what a sub 8 is, or in this case, a sub 1. If you want to know a specific term, you use this one. Okay, you put the term that you want to figure out right here. You put one of the terms, your choice, as we said before, any term that you already know right here. I'll go ahead and do the 20th term, right? Why not? Okay, I'll put the 20th term right there. You could put A12 there. It doesn't matter. But because I picked 20, then what is this over here? This is going to be 1 minus 20, which is negative 19. So what I do is I say negative 19d. And then I plug in the appropriate things. Since I know what d is, and since I know that A20 is equal to, what is A20? A20 is equal to 84. I then put 84 right here. And I put my 3 right here. Let's do that. I'll actually write down what I'm just transferring this over first to the actual paper here. But then I'm going to plug in what? I'm going to plug in 84 into the 20th term, because that is the 20th term. And then I'm going to plug in the 3 right here. Okay, and then that gives me the formula for a sub 1. Okay, just following this right here. All right, A20. And so do order of operations right here. Again, do negative 19 times 3. If that's a minus sign right there, negative 19 times 3 is negative 57. So that would be 84 plus negative 57, which is the same thing as minus 57 when you add a negative, right? Okay. So the final answer, what is 84 minus 57? That is equal to 27. Okay. So it all comes down to figuring out what D is usually, because typically they're going to give you at least one term. Okay, they're going to give you at least one term. In this case, they gave me two. You just need to know. You just need to have knowledge of at least one term, and then you need to know D in order to figure out all the other things that we need to figure out here. And so D is the key thing in a lot of these problems. Okay. Okay, I'm going to go ahead and stop the video right here. What we'll do is in the second half of section 7.2, we'll have a second video, part 2, where we'll be looking at adding together, in other words, taking the sum of the first set of terms in an arithmetic sequence. Okay, that's on the back side of this worksheet. So for now, let me know if you have any questions. You have a good day, and we'll see you back for part 2 of section 7.2.